Start. Any question before we start? Okay, so today we are going to try to do two things. First of all, we are going to take another look at our production possibility frontier concept, and we are going to really try to answer one of the questions that were raised in the earlier class. It was related to why the production possibility frontier is not a curve rather than a straight line. And we are going to look at that again, and we're going to show that an actual production possibility frontier is indeed a curve, which means that the slope of the line really is not constant. So after we do that, we are going to spend some time just looking at some questions from this concept of production possibility frontier. And then we are going to move on to the next concept, which is a very lengthy discussion about trade. So we have, I would like to utilize my class time efficiently today because we are sort of falling behind the other class that I'm teaching, and sometimes it creates some misalignment. So let's move on. This is what we have covered in the previous class. We are trying to develop this idea of a production possibility frontier. By definition, our production possibility frontier shows the different combinations of goods and services that an economy or an individual can produce when all the resources are fully utilized. And we are looking at an example where Tesla can produce two goods, SUV and sedans, and the schedule that we're looking at, A, B, C, D, and E, shows different combination of goods that Tesla can produce. Notice that in these combinations, something is very important, and it is that whenever Tesla tries to produce more of one good, it has to give up producing the other good a little bit. For example, when Tesla is moving from A to B, it can indeed produce less sedans by moving from 80 to 60, but what it gains is in terms of SUV productions, right? Do we all see that? Did we cover this in the last class? Yes. Okay, please, thank you for reminding me. Where did we stop? Sorry? Okay, so we have seen how to derive this production possibility frontier. That saves me about 15 minutes, which is kind of a big deal. Okay, so our production possibility frontier is a straight line. And then we looked at some points that are also important, like points like F, which is inefficient, and G, which is like unattainable. It is unattainable, given the resources of the economy. That is a very critical point because anytime the resources of the economy change, something that was previously unattainable could become efficient, and something that was efficient before could become inefficient. So let's look at that. Before we do that, I think we need to now start taking a more serious look at a shape of the production possibility frontier. So the shape of the production possibility frontier is dictated by the trade-off between the two goods and services that production possibility frontier really reflects. If we want to go back to the original data that we have, our original data suggests that anytime you give up about 20 sedans, you gain 20 SUVs. Do we all see that? It seems like the resources that the Tesla has are equally applicable to these two production. Right? Sometimes they are called perfect substitutes, something that we're going to look at in a future chapter. It seems like they are perfect substitutes in the sense that any resource that can be applied to the production of a automobile, to a sedan, can be equally applicable in the production of SUVs. So it seems like Tesla can make one SUVs, and if it gives up producing that SUVs, it can gain one sedan. So for Tesla, in this artificial example, the trade-off is 1-to-1. Do we all say that? This trade-off has a more formal terminology that we have seen in the previous class, which is called opportunity cost. Opportunity cost refers to how much you give up when you produce something. In this particular example, Tesla is giving up one SUVs to gain one automobile and vice versa, right? So the slope, which also indicates the opportunity cost in this production possibility frontier, is constant. It is always 1. Do we all see that? For every 20 automobile Tesla gives up, it gains 20 more SUVs. So the opportunity cost between an SUV and an automobile, a sedan, is 1-to-1 for Tesla. This is obviously not true in reality. Why? Because in reality, most of the resources that we use are kind of specialized, meaning that there are, most of the resources are better applicable in one sector or in one production compared to the other one. This specialization nature of resources makes our production possibility frontier a curve rather than a straight line. Let us try to understand this concept from another example perspective. Now imagine that we are looking at a different economy where the economy is trying to produce tanks and automobiles. This is very similar to the Samuelson kind of example, right? Bread, butter and guns. He's talking about. They are talking about tanks and automobiles. By the way, two different kind of production, right? There are similarities between the production of a tank and an automobile, but in many sense they are very different, right? Imagine that you are at a situation where you are only producing tanks. You are at point A on the production possibility frontier. So at point A, you are only producing tanks, and suddenly your economy is telling you that they need some automobiles. So what do? You say that, well, I'm going to reallocate some of the resources from the tanks to the automobile industry. So what do? You give up producing some number of tanks, in this case 50. You give up producing 50 less tanks and allocate that resources to the production of automobiles. Let's now start looking at the automobile industry. So the automobile industry was non-existent before. Do you all understand that? They were not producing anything. Suddenly, they get a blessing of resources from the tank industry. The industry, completely fresh, all the machines are fresh, all the workers who are working in the automobile industry were not working, right? Suddenly they get work, and we argue in economics that at the initial stage of production, people are more productive. Resources are more productive. So when you set the first batch of resources to the automobile industry, they end up producing a lot of automobiles, 200 of them. Do we all see that? Does it make sense? But this idea of resources being more productive at the beginning of the production and later decaying will be analyzed again in a couple of chapters later, where we are going to call that law of diminishing returns, a very important concept for your exam number 2. In this case, we are just moving from A to B. We are just moving from A to B. The economy is giving up producing some tanks, and it is gaining a lot of automobiles. So that's good. When you move from A to B, you gain a lot of automobiles by giving up few number of tanks, because you are at the initial stages of production, everything was fresh. Now, as you try to produce more automobiles, right, because your economy needs more automobiles, you have to reallocate further resources away from the tank industry. And that might create a problem. Why? Because some resources could be really specialized in making tanks. Are we all clear on that? When you take those resources away from the tank industry and force them to work in the automobiles, will they really be productive? Will they really be effective? So this is like, making, sort of like a non-skilled person to develop a software for which he doesn't have any skill at all, right? Right? Make sense? Skills are important, right? Specialization. Because every skill or every resource that we have certain degree of skill in our economy, some certain degree of specialization in our economy. So the argument is as follows. If the economy tries to produce even more automobiles by giving up more tanks, the economy can produce more automobiles, but it will no longer be equally efficient or equally productive. Okay, how do we show that? In the next one, we are going to move from B to C. When we move from B to C, we are giving up about 150 tanks. Do we all see that? We are giving up about 160 tanks, and we are gaining in another 200 automobiles. Is the economy equally productive as it was at point B? Is the economy equally productive at point B and at point C? The economy is, but is the automobile industry equally productive? The distinction between them is very critical. Why do we say that the economy is equally productive? The productivity of the economy or the efficiency of the economy hasn't changed. How do we know that? Yeah, you're still on the production possibility frontier, and as long as you are on the production possibility frontier, regardless of where you produce, whether it's A or some point like D where the economy is only producing automobiles, you're always productive. You're always efficient from an economist's perspective. But inside the economy, there are different sectors, and they are not equally efficient because the resources that they are using are not equally productive in all the sectors. When the economy was moving from A to B, the economy was allocating some initial resources to the automobiles industry. They were very productive, but further reallocation of the resources from the tank to automobile are no longer that productive. And you can see that. Initially, when the economy was giving up 50 tanks, it was gaining 200 automobiles. Now the economy gives up 150 tanks, it still gets that 200 automobiles. So we can see clearly that the opportunity cost of making automobiles is going up. Do we all see that? What was the opportunity cost of making automobiles when the economy was moving from A to B? Notice that when the economy was moving from A to B, the economy was giving up 50 tanks and gaining 200 automobiles, right? So what is the opportunity cost of making one automobile? Anyone? It's not 1/4. So you are gaining 200 automobiles and giving up 50 tanks, right? So the opportunity cost of one automobile is how much? How many tanks? It has to be less than one, right? Isn't that true? You give up 50 tanks, you gain 200 automobiles, right? So how much tanks are you giving up when you are producing one automobile? So in order to produce 200 automobile, you are giving up 50. In order to produce one, you are giving up 50 divided by 200, right? And that's the opportunity cost of going from A to B. How much is that? That's about 1/4. Isn't that right? Am I?
That's right. That was the first answer.
Sorry?
That's right, but that's what he said first.
Oh, I didn't hear that, or I didn't understand that. I apologize. Okay. So what is the opportunity cost of going from B to C? So when you go from B to C, you give up 150 tanks and you gain 200 automobiles. So it's going to be 150 divided by 200 tanks. So that's the opportunity cost of going from B to C. So what is 150 divided by 200? I forgot. It's 3/4, right? So that's like, how much is that? That's like 0.75, right? So this was 1/4, and this is 3/4, right? So what are we noticing about the opportunity cost as we move from A to B to C and even further? Are we all clear that the opportunity cost of producing automobiles are going up from 1/4 to 3/4, and if you go even further down, opportunity cost is going to go up. So two conclusions sort of can be made from this production possibility frontier. The first one is that as we move down the production possibility frontier from the upper part to the lower part, the opportunity cost increases. Now that one has an equivalent observation in terms of the slope of the production possibility frontier. Hopefully this week or already last week your SI leaders have talked about how you can calculate the slope of the production possibility frontier. The slope of the production possibility frontier as we move from A to B to C to somewhere down, the slope increases. The slope increases. So we now have therefore three equivalent observations. The first observation is that as we move down from upper part of the production possibility frontier to the lower part, the opportunity cost of goods that are measured by the horizontal axis increases. The second observation is that the slope of the production possibility frontier increases, and this is due to an increasing marginal cost. So as you produce more and more automobiles, the opportunity cost of producing automobiles are increasing. So it is called an increasing marginal opportunity cost. All of them give us the same impression that our production possibility frontier in reality is not a straight line, meaning that the slope of the production possibility frontier is not constant. It actually changes. More importantly, as we move from the upper part of the production possibility frontier to the lower part, the slope actually increases. Okay, so that sort of concludes our discussion about the true nature of a production possibility frontier. It is always going to be a concave, it will be a curve, it will be a concave function. Any question? Okay, now the next two concepts are related to what makes this production possibility frontier shift or change. There can be two kinds of changes of the production possibility frontier, and all of them are related to the resources that we have in an economy. Remember, the production possibility frontier really gives you a graphical illustration as how the economy is utilizing the resources. Right? We can think about the production possibility frontier changing in sort of two different ways. First of all, we can imagine the overall resources of the economy changing. What do you mean by that? By an overall resource of the economy changing, we are referring to, let's say, discovery of natural resources that is beneficial to every sectors of the economy, like oil, like natural gas, which is used almost everywhere. Or also we are talking about situations like a natural disaster that destroys all the natural resources of the economy, or some capital stocks, some machines that are used in the production process. Whenever the overall resources of the economy changes, our production possibility frontier shifts, either to the right or to the left. The one that you're looking at is a situation where there was an increase in the availability of resources. Imagine that the original production possibility frontier is the lower one. Okay? The original production possibility frontier was a lower one. A was a point that was on the production possibility frontier. A was efficient, right? Given the original resource of the economy, point B was unattainable. Do we all see that? Given the original resource of the economy, point B was unattainable, then there was growth. The economy suddenly found a lot of resources, which shifted the production possibility frontier, upward or sort of to the right. When a production possibility frontier shifts like the one that we're looking at, notice that point B, which was unattainable before, is now efficient because it is on the production possibility frontier. That is a possibility, right? So due to growth, previously unattainable combinations of production could become feasible and efficient. It could be the other way around too. Imagine that our original production possibility frontier was the black one, and we were at point A, and suddenly there is a natural disaster or a war. Something that destroys the overall resources of the economy, and when it does, it shifts the production possibility frontier to the left. If the production possibility frontier shifts to the left, A, which was efficient before, is now unattainable. Make sense? This is only one kind of change in the production possibility frontier that can happen. This is called a shift of the production possibility frontier. Anytime the production possibility frontier shifts to the right, we call it economic growth, a very, very important concept in our economics. Economic growth occurs when the economy finds new resources that leads to an overall increase in the production of the economy, causes production possibility frontier to shift to the right. The other kind of changes in the production possibility frontier can happen on an industry level. Okay? By the way, I want to go back and point out that finding new resources is not the only way production possibility frontier can shift to the right or to the left. Economists argue that the most important way through which production possibility frontier shifts to the right is through technological innovations. Technological innovations, a very powerful concept in economics. Your macro courses will have more emphasis on technological knowledge. There is a chapter where we are going to talk about production, and then we are going to bring back the idea of technology. But to put a very operational definition at this point of time, technology means finding, improved ways of producing things. So if there is a technological improvement like a steam engine, like in invention of electricity that affects all the productive activities of the economy, your production possibility frontier can shift to the right. But then you can have sector-specific technological change. So sector-specific technological change are very common. You can think about a certain, like an assembly line production process in automobile industry. That was a industry-specific technological change. Anyone familiar with what an assembly line is? We are going to come back to the idea of assembly line at least twice this course and many, many times in your future economics courses. Because when we look at the modern innovations that were made in the last 100 to 200 years, assembly line is considered to be a technological innovation, but it is a sector-specific technological innovation. When you have a technological innovation, let's say in the automobile industry, you can see that the production possibility frontier really pivots rather than shifts, meaning that the vertical axis remains the same. The only thing that changes is that the horizontal axis kinda, changes, meaning that the economy with its available resources can produce more automobiles, but the amount of tanks it can produce is still unchanged, because assembly line really doesn't affect the tank production. Tanks are not made in assembly lines, at least not in USA. Makes sense? So when you have an industry-specific technological change, when you have an industry-specific economic growth, like finding new resources that affects only one industry or one sector of the economy, our production possibility frontier will pivot. This is called a pivoting of the production possibility frontier. Okay, so this was a positive pivot where the production possibility frontier pivoted to the right. Because of some destruction of industry-specific resources, production possibility frontier could also pivot to the left, just like we saw in the growth case. That concludes our discussion of the production possibility frontier. Does anyone have any question? I want to quickly move to some questions that I'm skipping the PPF for exam grade. Please read that on your own. Let's look at question number, this question. So what do you think? Which one is the correct answer? Anyone? Somebody said B or D? B. Okay. The country is maximizing its opportunity cost. So what does that mean? What does maximizing opportunity cost mean? Meaning that it is producing everything with the maximum possible opportunity cost. Is that what we want? This is not a trivial question. So is that what we want, to produce everything with the maximum possible opportunity cost? That's actually the other way around. We want to produce things at the minimum opportunity cost. That was the definition behind the productive efficiency. Do you remember that? Productive efficiency was an idea where we said that everything we want to produce has to be produced at the lowest possible cost, opportunity cost. Because that's how you can minimize your cost of production, and that's how probably you can have a better allocation of resources. So B is not the correct answer. So if B is not the correct answer, what else could be? Okay, so notice that the question is a sort of a reinterpretation of the definition of the production possibility frontier, right? And some of the questions that you will see in the exams are going to just ask you basic definitions. And there is nothing beyond that. It's just going to see whether you know the definition of some concepts. And this is one of them. And the only way to remember them is memorize them. And people have done that in various ways. Some people like to keep flashcards. Some people like to write those concepts and memorize them. Do whatever you have to do, but these are the concepts whose definitions are going to be in the exam. And I mentioned that, I think, several times. So the correct answer is A, because B cannot be the correct answer, so D also cannot be the correct answer. Can C be a correct answer? If the economy is producing on the production possibility frontier, let's say, that's the definition, right? Does it mean that we have eliminated our scarcity problem? We really cannot, right? Scarcity problem simply doesn't go away. Just like, your age doesn't go away. You sort of age and die, right? So that's like a peculiar way of looking at growing up. So the correct answer is A, right? Okay. So the next one. Answer? Okay, so do we see that, point G is clearly unattainable, right? Point G is clearly unattainable. So G is unattainable. What about F? F is inefficient, right? So please remember that. So the correct answer is A. Let's look at the next one. This is an interesting one. I'm recording this video lecture because I'm going to upload that to my other class, because this is the question that I did not go over with them. Which one is the correct answer? Anyone? So there is a B answer, there is a C answer. Anything else? How many of you think that B is the correct answer? Please raise your hand. There is nothing wrong with raising hand. Okay, how many of you think that C is the correct answer? Most of the people are indifferent. Or do you think that there is anything other than those? Does anyone think that A is the correct answer? Or This is not a trivial problem. This is not a trivial problem. Why? Because when we are looking at the number of cakes you are making 5 cakes, right? And it might seem that, well, when I am not producing any pies, am I really giving up anything, right? That's why many of you are thinking that the opportunity cost is just 0 pies. It's not true, right? When you are producing only cakes, you are giving up the possibility of producing a lot of pies, right? How do we know that? The best way to start look at this problem is from the horizontal axis. Okay? So imagine that you are producing 10 pies and you were not producing any cakes, so you were not giving up any cakes. When you give up 2 pies, you gain 1 cake. Do we all see that? So what is the opportunity cost of making 1 cake? The 2 pies that you give up, right? Do we all see that? When you give up producing another 2 pies, you gain another cake, right? So the opportunity cost of making 2 cake is actually 4 pies that you are giving up. In the similar argument, the opportunity cost of producing 5 cakes are the 10 pies that you are giving up. 10 pies. So the correct answer is C. Any question? This is just a definitional question. This is increasing marginal opportunity cost. I don't want to spend time on this one. This is just a definitional. And these are the questions for which you really need to know the definition. There is no way to guess these ones as the correct answers. If you try to guess for these, you will most of the times make a mistake. So I'm going to skip that. I want to spend a little bit of time on this one. That will be the last question. Okay? Before I request for an answer, I want to point out that one of the key things in answering multiple choice questions, and I am sure you have heard this many, many times, and I want to reiterate on that one more time, is that you have to read the question properly. You have to read the question at least once before you look at the answers. Okay? And this is one of those questions for which it is extremely important to read the question. This question is about, the whole economy having more resources. Are we all clear on that? So if the whole economy has more resources, that is going to be represented by which kind of shift? What's the answer? So the correct answer is clearly A. So the correct answer is clearly A, but if I just change one word, which graph best represents an increase in economy's sector-specific resources? If I just add one word, or if there is an increase in one sector's resources, something like that, it's going to be a pivot, right? This is how serious reading this question is. That concludes our discussion about production possibility frontier. Does anyone have any question? Okay? What I'm going to do, I'm going to quickly start the next concept. The next concept in this chapter is all about trade and specialization. Why do countries trade? Why individuals trade? Is there any need for trade? Very basic economic questions. Trade is equivalent to exchange. Through trade, countries and individuals exchange goods and services. So the deeper question that we are asking is exchange beneficial to us? Does exchange make our life a better one? We are going to bring flavors of classical trade theory in this particular discussion. Those of you who will take upper level courses on international trade, international finance, intermediate macroeconomics, these concepts will again be discussed in a more advanced context. But we want to start today by talking about the fundamental intuition behind why trade is important and what exchange gives to an economy. Our story about trade actually starts from another story. It starts from story and not from theory. And the story starts, our story starts with this famous classic story named Robinson Crusoe. Anyone familiar with Robinson Crusoe? If some of you end up in graduate level studies in economics, you will realize that many of our classic theories, starting from what we are looking at right now to how money was developed, were heavily influenced by this classic story that was written so many years ago. So you guys have seen an Hollywood version of this story. The name of the movie is Cast Away by Tom Hanks. And the story is actually about a guy who gets stuck in an island. And he has to do everything by himself, right? He has to cook, he has to catch fish, he has to light a fire. He has a scarcity problem, right? His scarcity is mainly the time that he has. He has only 24 hours. In that 24 hours, he has to catch fish, cook fish, eat that fish, sleep for a while, and it's a serious problem for him. The problem is not evident when he is all by himself, right? This is where the Castaway movie sort of deviates from the classic story. So in the classic story, Robinson Crusoe is doing everything by himself. He's cooking, he's catching fish, and then after a while, a second character is introduced in that story. His name is Friday, and he also gets stuck in the same island. Now, when there are two people, then things start becoming interesting in the sense that they realize that they can specialize. Although both of them can cook, both of them can catch fish, they realize that they can specialize by one of them focusing on some things that they are good at, the other person doing other stuff that they are good at, and they can exchange those goods. Okay? Are we all clear on that? Now, this is the motivation for looking at the theory that we're going to look at. There are also some other serious motivations, and in due time I'm going to talk about that. One of them being why USA trades with China anyway. Is there any reason? Is there any benefit? So trade or exchange is based on very simple ideas. It's based on the idea that sometimes rather than doing all by yourself, you should only focus on things that you're good at, specialize on those, and then exchange or trade your goods and services with other person, and everyone will be happy. Both of you will be happy. Both countries will be happy, both individuals will be happy. If that is true, then trade really benefits everyone. Are we all clear on that? Our discussion about trade, unfortunately, is very superficial in this chapter, and for reasons that is beyond my understanding, this is not a well-written chapter. I am teaching several online courses this semester, and in one of the courses, I will be recording video lectures for that class, and that class uses a different book that does a better treatment of the trade. Once I record those videos, I'm going to upload them for you guys to take a look at, so you can also get a better understanding of how trade happens. What we're going to do now is we're going to start very slowly with a very fundamental ideas, and the fundamental ideas are going to be based on stuff that we have looked at. One of them being this idea of opportunity cost. Opportunity cost is at the heart of what we are covering in this part of the chapter as well. There are several names associated with what we are looking at right now. One is, whose name is the most important one, is David Ricardo. David Ricardo was a Latin economist who got a Nobel Prize in the late 60s because of the theory that he developed, and the one that we're going to look at. Okay, so let's start our story by looking at two individuals, you and your neighbor. And two activities that you can do. You can pick cherries, you can pick apples. There is no specific mention about the scarcity of resources. Probably we know it's time, right? Let's look at how you can allocate those time in your economic activities. For you, if you devote your entire time in apples, you can pick 20 pounds. If you allocate that for cherries, you get 20 pounds. So for you, it seems like you are equally efficient in picking cherries and apples. Are we all clear on that? Your neighbor, however, can pick a maximum of 30 pounds of apples and a maximum of 60 pounds of apples. His specialization is slightly different, and that's what sort of initiates interesting discussion. So are we all, please take a look at the numbers. So for you, it's 20 apples and 20 cherries. For your neighbor, it's 20 apples and 30 apples and 60 cherries. We can put these numbers into a production possibility frontier. For you, your production possibility frontier looks like this, right? This is a very simple way of drawing a production possibility frontier, where in order to draw the production possibility frontier, what you are doing, you're finding the maximum amount of horizontal good that you can produce and finding the maximum amount of vertical goods that you can produce. You find those 2 points, let's call them A and B, you add them and you get an artificially looking straight line production possibility frontier. But that is sufficient for us to understand trade. We don't need a really concave, realistic looking production possibility frontier. So for me, my production possibility frontier is that it's 2020, and for my neighbor, his production possibility frontier is slightly different, but it's almost the same in the sense that it is still a constant slope, a straight line, but it also captures his production possibilities. Notice that the maximum number of apples that he can produce is pick up is 30, the maximum number of cherries that he can pick is 60. Do we all see that? Now, I'm going to go over the material from this chapter in a slightly different order than what the book slides are doing. I'm going to open a Microsoft Word and I'm going to start calculating the opportunity cost of these two people. Because opportunity cost is going to tell me who is going to do what. So I'm going to say that for me, the opportunity cost of 1 unit of apple, AP, is 1 unit of cherry, right? If I pick 1 apple, I give up the possibility of picking up 1 cherries, right? Pound, whatever, units don't really matter. Are we all clear on that? Are we all clear on that? For me, the opportunity cost of 1 unit of cherry is giving up 1 unit of apple. So for me, the trade-off between apple and cherries are pretty straightforward. On the other hand, when I think about my neighbor, the opportunity cost of 1 unit of apple is how many units of cherries? So my neighbor can pick 20 apples, or he can pick up 60 cherries. So if he pick up 1 apple, he gives up the possibility of picking 2 cherries, right? That's the opportunity cost. So the opportunity cost of picking up 1 apple are 2 cherries, and the opportunity cost of 1 unit of cherry is about half apples, right? We have these 4 numbers, and these 4 numbers are the basis that are going to determine how trade is going to take place. Let's look at these numbers very carefully. When I look at myself, it seems like I am equally efficient in making apple or cherries. I am equally good at them, right? My neighbor, however, has some kind of skill differences between his cherry picking and his apple picking, right? Let's look at the basic numbers first. If we go back, and I cannot go back because this will delete that. If you remember the numbers, I can pick up 20 apples or 20 cherries. My is that 20, right? Can anyone check that?
It's
And what about my neighbors?
30-60.
It's 30-60, right? So it is obvious that my neighbor is kind of more efficient than I am, right? He can do everything better than I do. When an individual or a country can produce everything more efficiently than the rest of the world, we say that the country has an absolute advantage. When a country can produce everything better than the rest of the world, in this case there are just two countries, or two persons, the person is supposed to have an absolute advantage. In this case, our neighbor has an absolute advantage over the production of cherries and apples. Right? Now, our absolute advantage really does not tell us whether these two people should trade. This is a very critical question, because when a lot of people look at the trade between USA and China, they argue that USA is obviously more efficient than China in producing computers, and USA is also probably more efficient than China in making ready-made garments. So why is that USA produces computers and sells them to China and buys ready-made garments from China? Are we all clear on the question? So the trade economists argue that absolute advantage is not the way to understand trade. Something else is. And that else is what David Ricardo used to call as comparative advantage. Comparative advantage is when one person or a firm or a country can produce a good at a lower opportunity cost than everyone else. In this case, since there are just two countries or two individuals, if one country or one individual can produce something at a lower opportunity cost than the other country or other person, then the person is said to have comparative advantage. I can assure you the definition will be in your exam. Okay, so if that is the definition, let's look at the numbers. So notice that when you look at apples, the opportunity cost of apples for you is 1. The opportunity cost of apples for your neighbor is 2. So you have a lower opportunity cost in picking up apples. Do we all see that? So our competitive advantage tells us that, theory of competitive advantage tells us that you have a competitive advantage in the production of apples. And notice that your neighbor has a lower opportunity cost in picking up cherries, because half apples is greater than one apple, smaller than one apple. So your neighbor has a lower opportunity cost in picking up cherries. So your neighbor has a competitive advantage in the production of cherries. Summarize. You have a competitive advantage in the production of apples. Your neighbor has a competitive advantage in the production of cherries. So that tells you that if you really want to specialize, you should produce only apples, and your neighbor, if he wants to specialize, he should only produce cherries. I am out of time, right? Yeah. Okay. Thank you very much. There are 2 minutes. I don't want to go any further. So we would like to finish this chapter by Wednesday, which is in the next class. And after that, I will upload the first quiz and the first homework. So please, if you have not yet registered to MyCon Lab, do that as soon as possible. Thank you very much.